Hi guys, so I'm just going to do the Blackboard here, and you can see we're still downloading the video that I made earlier in front of this where I did the demo, but I'm going to just do the notes part of at least, maybe I'll do about 15-20 minutes. I'll just do the current carrying wire notes, and then we'll maybe save the solenoid for next day, depending on how much time. I don't want to go too long, as the demo part was about a 25-minute video, so I want to keep this one to about 15 at most. Okay, so as that opens up, what we're going to look at today then is the first right-hand rule, magnetic fields about current carrying wires. Okay, so we will do that. Okay, so let's just set that up. We're going to do some drawings, of course. All right, so this is day, I forget now, day 14, I think. Not sure. Let me look. It is day 14. Okay, and then we're just going to be looking at the right-hand rule for a current carrying wire. Okay, and that's what we're going to look at today. We already did the demonstrations and we looked at it as well for a solenoid, but we probably won't get that far in terms of our drawings because I don't want to make the class really long in terms of minutes. Okay, so what we're going to do is we're going to summarize a couple of things here with the right-hand rule and this stuff. So let me just get my background notes on the other side here set up. All right, so first thing we're going to say is that the induction of a magnetic field in the presence of current, okay, happens all the time. Okay, so when we'll word like this: when you have a flowing current of electricity a magnetic field is induced or created. Okay. Wherever there's a flow of electrons, there will be a magnetic field. Okay. We're going to look at the first one. We're going to look at is the magnetic field around around a current carrying wire. That's probably all we'll be able to draw today. Okay, and we're going to do the right-hand rule. Okay, the first thing I have to tell you is that some books will do left-hand rule because they talk about moving electrons. So we are going to use the right-hand rule. And remember, the right-hand rules apply to conventional current. Not electron flow current. Okay. Conventional current is they're assuming that the positive particles are moving and that the positive lead in the battery is live. Electron flow current says electrons move and the other way around. And we use conventional current because that's what is out there in the electrical field. Okay, so the right-hand rule states this. Okay, let's use different colors so that we can state it. I already stated it already in the demo video, but let's type it out here. grab the wire with your right hand. Okay. Point your thumb in the direction of the current. Remember, we're talking conventional. Okay. Your fingers will curl around the wire in the direction of the created or induced magnetic field. Okay, so let's draw it out here. Okay, I'm going to draw a couple of pictures. Okay, so if we have a wire, so and let's say that the current is going this way. Okay, and if we take our right hand and we grab it, okay, grab that wire, point it, so the field is going to curl below the wire and around like this. So we'll do it a different color here. Okay, so it's going to come and curl around like that. Okay, so on the top of the wire, it's curling around like this. Okay, because of our right hand fingers curling around. I'm not going to draw fingers because that's not I'm not a very good drawer. So it's going on the top and then down around, on the top, down around. So this is the direction of the magnetic field. Okay, now if we do that with like just looking at a two-dimensional object, so if we kind of do a hollow, if we consider this a wire here, and we say that if we put a dot in it like this, that's like the tip of an arrow. That's like flowing out of the page. Okay, and if we do an X on the back like the feathers of an arrow, we say that that's flowing into the page. It flows into the page. Okay, so if we take our right hand rule and we say flowing out of the page, the magnetic field is going to curl around in this direction. Okay. If we say it's flowing into the page, the magnetic field, if we take our hand, we go point our thumb into the page, it's going to flow in the other direction. Okay, so those are our diagrams for current carrying wires. So out of the page. It's flowing around, okay, in the counterclockwise and then clockwise direction for into the page. Okay, so just think of the tip of the arrow coming at your head here out of the page, the back of an arrow going into the page. And here's a three-dimensional one. So we'll look here at our video here. I think we will stop here. Let's hit my preview here and see what we have for time. Okay, so we've done about 12 minutes, almost 12 minutes. So that this will be where we'll stop today, just with that drawing. Next day, I will start with the solenoid drawings, okay? And today you had about a 25-minute demo video and about a 12-minute here after I'm done talking drawing video. So once you've got through these two, you should be good. And we'll do the solenoids the next day, and we'll talk about also induced magnetic fields and the motor principle as well, if we get that far. Okay, so we'll do that next day.